Hey guys, today we're going to solve some equations using properties that we've already learned for logarithms. So we've got log base 4 of 5 plus log base 4 of x, and from our previous lesson I know I can combine those or condense them into a single logarithm, log base 4, and since there's a plus here, I multiply the arguments. 5 times x equals log base 4 of 15. We've also learned that when we've got two logarithms, one on each side with the same base, if the bases are equal, then the arguments are also equal. 5x equals 15. We've also learned another trick that could get rid of these logarithms would be a base 4 on both sides. We don't necessarily have to do it that way, but there's a visual of another thing that we've learned. But here, if I divide by 5, I get x equals 3. And if I plug that 3 into the original for x, log base 4 of 3, I've got a positive argument, so I'm okay with that answer. If we're going to get a negative argument when we plug our answer back in for x, then I would have to throw that answer out. So here we can condense again because we have the same base. So we've got log base 3, and it's subtraction, so 2x plus 6 over x minus 6 equals log base 3 of 5. Equal base means equal arguments. So 2x plus 6 over x minus 6 equals 5. I'm going to multiply this across to the other side, and I'll get 2x plus 6 equals 5x minus 30. So I've distributed the 5 as I multiplied this to the right side. So I'll move that 2x over and get 3x on the right side. I'll move that negative 30 over to get 36. So 3x equals 36. I can divide and get x equals 12. If I plug that 12 in, 2 times 12 is 24, plus 6 is 30. That's a positive argument. 12 minus 6 is positive 6. That's a positive argument, so I'm okay with that answer. Log base A for both of these logarithms, so I can condense to log base A, 2x minus 7. I'm writing that as though it's a fraction, but it shouldn't be. So it's 2x minus 7 times 5 equals log base A of 15. I can save myself writing a step by just dropping these. So I've got 2x minus 7 times 5 equals 15. I can distribute the 5, or I can just divide both sides by 5 and get 2x minus 7 equals 3. Add the 7, 2x equals 10, and divide, x is 5. If I substitute that 5 here, 2 times 5 is 10, minus 7 is 3, so I have a positive argument, so that answer is okay. Okay, both of these have log base 10, so I can condense log base 10, or common log. 3x times 6x, that's 18x squared, equals common log 72. So I've got log base 10 on both sides. I can drop those. 18x squared equals 72. I can divide by 18. X squared equals 4. And then take a square root. X is plus or minus 2. So I've got two answers to check here. Positive 2. 3 times 2 is 6. 6 times 2 is 12. I get positive arguments for both. If I put in the negative 2, I get an argument of negative 6 and negative 12, so I have to throw out that negative 2. So my two solutions, x equals 2, x equals negative 2, I have to throw out that negative 2 because it gives me negative arguments. negative solutions can be kept if they produce positive arguments. So it's not about whether the solution is positive or negative, it's about whether it produces a positive or negative argument. All right, so here I've got the same base again, so I've got log base 7 of x minus 5 times x plus 7 equals log base 7 of 13. Okay, same log on both sides, so those can be dropped. And I'm going to distribute here. I get x squared plus 7x minus 5x is plus 2x, and then negative 35. I have an x squared and an x, so I want to get everything to the same side and set equal to 0. So x squared plus 2x minus 48 equals 0. So two numbers that multiply to make negative 48 and add up to 2. I think those numbers would be negative 6 and 8. Negative 6 times 8 is negative 48. Negative 6 plus 8 is 2. So my factored form is x minus 6 times x plus 8 equals 0. So I get two solutions, x equals 6 and x equals negative 8. Okay, so when I plug in the 6 minus 5 is 1, that's a positive argument. 6 plus 7 is 13, that's positive. So this solution can be kept. When I plug in the negative 8, minus 5, I've got negative 13, plus 7, I've got negative 1. So I get some negative arguments, so I have to throw that solution out. So here I've got log base e, which is the same as natural log. So when I rewrite this condensed, I'm just going to write natural log. Natural log, and then x times x minus 1 equals natural log 12. Okay, so no magic in this natural log. Log base e is natural log. Okay, I've got log base e or natural log on both sides, so I can drop those. And then I'll distribute x squared minus x equals 12. Since I have an x squared and an x term, I'll set equal to 0. X squared minus x minus 12 equals 0. So if it's factorable, then there will be a pair of numbers that will multiply to negative 12 and add up to negative 1. And I believe those numbers are negative 4 and 3. Negative 4 times 3 is negative 12. Negative 4 plus 3 is negative 1. So it factors to x minus 4 times x plus 3 equals 0. So my two solutions are x equals 4 and x equals negative 3. So if I plug in a 4, I get a 4 and a 3 for my arguments. Those are both positive. If I plug in a negative 3, it looks like I'm going to have two negative arguments. Negative 3 and negative 4 will be my arguments. So I have to cross out that solution. All right, on the next page, I've got a pair of logs with a base 10 that I can combine. So I get log, and then subtraction means I'm dividing. 6x over x minus 3 equals 1. Now notice this time I don't have a logarithm on the right side, so I can't just cross the logarithm out. But since I have a log base 10, I can treat each side as a power with a base of 10, and that will cancel out my log base 10. So I get 6x over x minus 3 equals 10 to the first power, 10. Then I can multiply this over to the other side, and I'm going to distribute it. 6x equals 10x minus 30. I will Move the 10x to the left. Negative 4x equals negative 30. So x equals negative 30 over negative 4, which will simplify to positive, and then 30 over 4 is 15 over 2. X equals 15 halves. Okay, on number 8, first thing I need to do is move that over there as an exponent. So log base 5 of 6 to the 3rd power plus log base 5, 3x equals 2. Okay, next I can condense these to log base 5, and it's adding, so I'm going to multiply. And then 6 to the 3rd power is 216 times 3x. (216 times 3 is 648. Now I want to cancel out this log base 5, and I don't have a log base 5 on the right, so treat each side as an exponent with a base of 5, and I get 648x equals 5 squared, 25. So x equals 25 over 648, and that cannot be simplified. And last, before I can do anything with these logarithms, I need to take that 2, that coefficient, and turn it into an exponent. Log base 5, x squared minus 11 equals log base 5 of 5 to the 2nd power, which is 25. Okay, so now I can cancel my logarithms, and I've got x squared minus 11 equals 25. I can move that 11 over, x squared equals 36, and take a square root. So I get x equals plus or minus 6. It just occurred to me I have not checked solutions in these top two, so we'll go back and do that in just a moment. But first I've got x equals 6 and x equals negative 6 to deal with. So if I put in x equals 6, 6 squared minus 11 is 36 minus 11, and that's 25. Negative 6. Negative 6 squared is 36. Minus 11 is 25. So both produced positive arguments. So I can keep both solutions. So this 15 over 2 is 7.5. 6 times 7.5 is a positive number. 7.5 minus 3 is a positive number, so that is okay. 25 over 648 times 3 is going to give me a positive number, so that solution is okay, so I'm able to keep both of those.